So I have pulled up now a tab of a web browser, and I'm just going to show you how you could use on your own computer whatever browser you have to find the tool we'll use to solve direction fields. So I've gone ahead to Google. You can use whatever search engine you like, and then you just need to type into the search bar dfield, D-F-I-E-L-D, or direction field, and go ahead and hit search. And it might not be the first result, but you need to go to the result that's hosted at uark.edu, the direction field plotter from the University of Arkansas. And it'll take you to a page like this, and it's like kind of old-fashioned, but it does work. And what you have is a box where you can type in your differential equation, and then some places where you can tweak the display, like how much of the XY plane it shows you or how many arrows it's going to put. And then this button, graph phase plane, is going to actually generate the direction field. So down here in this graph is that picture we made with all those little red arrows. And then in order to see a specific solution, what you're going to do is just click anywhere on the graph, and the point you click at is that x0, y0 that you want your initial condition to be. It's going to follow the differential equation in this box, and the line is going to show you the solution to that initial value problem. It's a really nice tool, and it's really easy, and it's a way for you to see solutions to a bunch of differential equations before we know how to solve them. The only thing is that it has like a few quirks that you just need to be careful about. So the first one is that if you'll note here, the variables that dfield expects to receive are y and t. So it receives differential equations dy dt equal to some function of t and y. In this case, t is like our x, and y was the same. So whatever dependent variable you have, you need to call it y, and whatever independent variable you have, you need to call it t. So for example, if you had a differential equation that was du dx, you need to rewrite it so that u becomes y and x becomes t. So in our case, we had that 0.2 xy as our differential equation. All I'm going to do is I'm going to say, okay, I'm not supposed to use x, I'm going to use t instead, and then I'll be fine. But if I hit graph phase plane, nothing's going to happen right now. And that's because this little blurb on the side here is kind of important. It doesn't recognize multiplication as things that are next to each other. So you do have to manually type that star symbol for multiplication. So 0.2 ty means 0.2 times t times y. Just make sure if you try to plot something and nothing's showing up, check whether those multiplication signs are missing. That's usually what's gone wrong. You also need to like put parentheses around like the input to sign or an exponential. But now that I've added in those stars, we have a direction field that looks kind of like the one I drew, much better, of course. And if we wanted to go ahead and do the example problem that we had in the previous video, I had like x0 and y0 were negative 10 and 10. Right now my display goes from -5 to 5. So see here my axes only run between -5 and 5. So I would just have to change that. I'm going to go ahead and take it out to -15 to 15. That way we can kind of like see the 10 in there somewhere. So these are my lower bounds for the x-axis, upper bounds for the x-axis, lower bounds for the y-axis, upper bounds for the y-axis. And I just hit graph again, and now I can see, for example, if I wanted to do that -10 problem, that's about here. And if I click, I get a solution that's very flattened out because the arrows are much steeper than I drew it in my picture, but that's okay. And you can see here it shows you the initial conditions that you actually clicked on. And I was a little bit off the mark, so if you wanted to be like super accurate, you could go ahead and type them here and then click that button to trace out the path. It's the same as clicking somewhere on the graph. And so similarly, if I wanted to do that minus 10 problem, oh, I messed that up. It would be kind of like that. And I think that's all I wanted to tell you to be careful about for direction field. So just go ahead and try opening this up and playing around with it.